Hello, this is Ram Mohan Bobili. I am a supply chain person. I have worked in multiple industry segments, including poultry. I thought that poultry is a unique industry by itself, not like any other manufacturing sector, with its own pain points and industry-specific requirements, which are unique in nature. The main purpose of this presentation is to tell you briefly about poultry industry and how the poultry processes can be mapped into SAP. This is the brief agenda of this presentation. Okay, I will briefly talk about the industry pain points, poultry processes, and recommended mapping in SAP, KPIs and reports, and the value proposition. And these are the industry pain points. We have evaluated the pain points of the poultry industry and identified industry-specific business scenarios to address the pain points in SAP. And for you, being aware of the business scenarios will help in having a meaningful conversation with customers. It will also help you with the information you need to ensure the customer that SAP is the right solution for the poultry industry. So most of the important pain points in poultry industry is the traceability throughout production, starting from grandparent farming to the final chicken on your table. And they use multiple SKUs. Okay, when the day-old chick comes, they come in number, but when they go to the slaughterhouse, they go in kgs. And they have problem with inventory too. They have very high unplanned inventory levels due to price fluctuations, particularly in the feed manufacturing side. Okay, they buy corn whenever the price is low, they stock up and utilize that when the price is high. And also there is frequent changes to the formula of the feed mix because of the requirement at the poultry. When birds are in different ages, different feed mixes are used. Also, whenever there is a epidemic like bird flu, the whole formulation will be different. They will start adding medicines to the feed. And the production environment itself is very complex. Okay, you start with a day-old chick, then you have a full-grown chick, then you start the egg production in the hatchery. Again, you start with the day-old chick in the breeding process. Okay, so the feed units keep changing, and each stage is complex by itself with its own requirements. Okay, so at each stage, the health of the bird is of very high importance. It has to be monitored continuously, and also the weight of the birds are monitored continuously, based on which the feed everything is altered. And the slaughtering process is very complex. Okay, so depending on the orders on hand, they have to decide on the number of birds to be culled in the slaughterhouse. Okay, and also they have issues with the transparency in yield and cost. So they don't know exactly how much yield will come at the end of the cycle, and what will be the cost or what will be the price. So they don't know exactly how much profit they are going to make or how much loss they are going to make at the end of the period. And the demand keeps fluctuating, and traceability throughout the production is the main issue here, because in the modern poultry industry, many farms are going for contract farming. Some parts of the process is contracted, particularly for broiler chicken. So traceability of the broiler chicken in being grown in different farms is a major challenge. And monitoring the weight loss is another issue. And it's not exactly an issue, it's the most critical requirement. So continuous monitoring of weight loss is required, and it has to be registered in a system. Okay, based on the weight loss, then they will take corrective steps in altering the feed formulation. And amortization of cost is another important issue, because the cost of egg is not just about the feed that was provided to the hen. Okay, we have to look at it holistically, starting from the day-old chick, okay, to the mortality of the birds in the farm, and the adding up of male birds cost to the female birds. So amortization is a very complex one, and there is stringent food regulation. So the quality checks at every stage is very, very critical. Okay, maintaining hygiene standards is also very critical for a poultry industry in view of the epidemics like bird flu. So this is briefly the view of a poultry supply chain. Okay, integrated poultry chain. It starts with grandparent chick and ends with a table chicken or eggs in different forms. It could be a whole bird, or a chicken sausage, or chicken soup. The list is unlimited. What happens from grandparent chick to the chicken on table is a complex story. Each step of the supply chain calls for continuous monitoring of progress and taking corrective steps immediately. Otherwise, the thin margins on which the industry operates will be wiped out. Some components of the poultry supply chain are outsourced to contract farms, mostly the broiler farms, as I have told you in the previous slide. Now, let us start looking at each component of the poultry supply chain closely and understand the imperatives for SAP implementation. The typical integrated poultry will have 5 business units, 5 to 6 including warehouse and distribution. So these are feed mill, grandparent and breeder farms, hatchery, broiler and pullet farming, slaughterhouse, and other producing value-added products like sausages, and finally warehousing and distribution. Poultry farms, particularly larger units, benefit from various government subsidy schemes to encourage investment in the latest broiler production and management technologies. In some countries, live birds are not sold or transported to reduce possible human infection with poultry-related diseases. It is important to mention here that biosecurity is the most important feature in the poultry sector due to avian flu epidemic in many countries. Procurement is normally centralized. Planning is done on a daily basis for ad hoc items and monthly basis for feed, medicines, vaccines, and chemicals. Let me take you through each component of the poultry and try to explain the critical requirement. This is the feed mill supply chain process. The first step to understand the poultry is to understand that the chicken don't eat the same feed in its life cycle. The feed composition keeps changing with the age and the progress of the chicken, which is typically measured by the average weight of chicken in case of broiler, quality and quantity of table eggs in case of layers. The feed also contains medicines like antibiotics to protect the bird's health. Special feeds are manufactured in case of special situations like bird flu epidemic. The demand planning comes in the form of different varieties of feed required by each farm well in advance. So planning is done at farm level, but validated and consolidated centrally in case of larger integrated poultry. The procurement is done taking into consideration multiple factors, including the market price fluctuations. Product costing and inventory management are the most critical requirements for feed manufacturing. Once the feed is manufactured, it is supplied to breeder farms, commercial farms, and external customers as per the order book and the delivery dates. And the grandparent farming supply chain is the starting point for chicken. Male and female chicks are usually reared separately until about 7 to 8 weeks of age. They are then reared so that they can work out who is the boss, adjust the order basically. They are then less likely to fight with one another later on. The growing period for layer breeders is from 9 to 24 weeks of age. The growth period is about 4 weeks less than the meat breeders. During the growing period, feed is restricted to prevent feed wastage and for layer breeders to improve egg production. It is important for meat breeders because they become too fat to breed efficiently if on full feed. Restricted feeding begins at the age of 6 weeks of age and continues until birds have commenced laying. When birds are at 5 to 10% of egg production, a breeder ration is supplied. Birds then have grown on restricted feed are often called control feed. Adult hens are the real workers of the industry. For the best performance, they need to be fed carefully and kept in a house at 21 to 28 degrees centigrade temperature. This means that the hen houses are designed to keep as near as possible to this temperature year round. The hens are checked regularly to monitor their health and medicines may be administered as needed. The quality of feed provided to hens may be varied for the level of production. Hens require more nutrients just before and during their peak production than at other times. This is called phase feeding. It can be economical to adjust rations for such high demand periods. The most critical requirement here is the traceability, also the mortality rates, and the amortization of egg value. Now let's look at the hatchery. Once the eggs are produced, they are supplied to hatcheries. Okay. These hatcheries are constructed in a special building with controlled ventilation. Hatcheries contain machines for holding and incubating large number of eggs. Hatchery is designed with hygiene in mind and also laid out so that there is little chance of any contamination. When the eggs arrive, they are set in trays marked with the shed of origin so that any problems can be traced back to the source. Hatching performance is also closely monitored and the end product is a healthy chick which goes on to become a commercial layer or broiler chicken. In the first stage of incubation, it is about 18 days and is called setting. The eggs are placed on special trays which can be tilted through 90 degrees from side to side. The temperature and humidity of the air in the setter is controlled so that condition inside each egg is suitable for growth and development of the chick. In the second stage of incubation, on the 18th day, the eggs are transferred to a different tray, which cannot be tilted, and placed in another machine called hatcher. Eggs are transferred to hatcher so that hatched chicken do not contaminate other batches of eggs being incubated. The hatchers can be thoroughly cleaned after every hatch. By the end of the 21st day, all chicks have hatched and are ready to be removed from the machine. And these day-old chicks are taken to a special room and removed from the hatcher tray. Some vaccines will be administered in the hatchery, and beak trimming is sometimes carried out, and in some breeds. They basically done for preventing further injury later in life. Let us look at the breeder farm supply chain. Breeder farm is very similar to the grandparent farming. Here also male and female chicks are usually reared separately until the age of about 4 to 5 weeks. The growing period for layer breeder is about 5 to 20 weeks of age. The growth period is about 4 weeks less than for meat breeders. So all the requirements are similar to the grandparent breeding, and here also the amortization of cost is very critical, and also traceability is very critical, and recording of mortality and culling is done on a day-to-day basis. So all these reports shown here are very critical for breeder farming. Let's look at the broiler farm supply chain. So in broiler farm, chicks are transported from the hatchery to broiler farms. That is the starting point. Usually in ventilated chick boxes, in specially designed air-conditioned trucks. And it is important that chicks receive warmth, feed, and water within a reasonable time of hatching. So these chicks can attain up to 72 hours without any food. On arrival at the broiler farm, the day-old chicks, typically we call them DOCs, they are placed onto the floor of the shed. Starter feed is given to ensure that they grow as much as possible early in life. This will continue for 18 to 24 days. Medicines are added to the feed of broiler chicks to prevent intestinal diseases. In growing stage, since the feed is expensive, very careful costing is carried out to keep the expenses down to minimum. So lower level of protein is fed from about 3 weeks of age to starter, which is commonly at 42 days of age. When heavy weight birds are required for filleting, they are slaughtered at up to 56 days of age. The first harvest might occur as early as 30 to 35 days, and the last at 55 to 60 days. So the most critical requirement here is monitoring the mortality and cull. Also record the medicine, feed, and vaccine given to the birds in the shed, and monitor the daily production report from the farm, and record the flock performance in terms of weight. So once the bird reaches the required weight, which is typically 30 days to 45 days, they will be transferred to stock points or directly sent to slaughterhouses. Now let's look at the layer farm supply chain. The layer farm sequence starts when the female chicks are raised into pullets for commercial production. Some farms raise layer chicks on a litter floor in shed, similar to broiler chicken. Pullets are either finished off or reared entirely in wire floored cages. These chicks typically go through brooding from 1 day to 8 weeks. Let's understand what is brooding. When a hen sits still for a prolonged period without eating or drinking normally, she is said to be brooding. This is a normal process during which the hen stops producing eggs in order to incubate a nest full of eggs. When the eggs hatch, the hen then cares for the chicks by keeping them warm and finding feed and water for them. Modern strains of the chicken have been selected not to go broody so that more eggs are laid. In this stage, the chicks need some additional heat depending on the temperature of the environment until the chicks can control their body temperature themselves. In growing stage, the chicks can control their body temperature. They still need to be protected from the extremes of climate. At this stage, they receive pullet grower feed, which is less expensive and contains only 15 to 17% protein and 7% less energy than the starter feed. And in the laying stage, the eggs will start laying eggs. The hens are the real workers here. And for best performance, they need to be fed carefully and kept in a house at 21 to 28 degrees centigrade temperature. And the quality of feed provided to hens may be varied for the level of production. Hens can need more nutrients just before and during their peak production than at other times. This is called phase feeding. It can be economical to adjust rations for such high demand periods. And these eggs should be, eggs from the layer should be collected regularly and transferred from the hen house to a net room where they are graded or checked for weight and for damaged shells. A sample of eggs is often broken open to check the internal quality. Eggs are typically packed into a carton for 12 eggs or trays of 30 eggs for sale. Prices vary with egg size, so eggs must be separated on the basis of egg weight. In big poultries, this is normally done automatically by a machine called egg grader. Now let's have a look at the slaughterhouse supply chain. The flock is liquidated from the broiler farms and sent to meat processing units. This slaughterhouse operation happens through the slaughtering machine. Subsequently, the actual weight of the flock is recorded. The output of the slaughtering operation is that we get birds of different weights, like 600 grams, 700 grams, 1 kg, 1.5 kg, etc. Until this step, we don't know, we are not sure about the weight as well as the different varieties. Then the whole chicken is bifurcated into A grade and B grade. And only B grade chicken are used for meat portioning, that is cutting into smaller pieces. There are different SKUs associated with the whole chicken that are obtained after the meat processing. Now, say if we want to plan for a particular SKU like wings for 10,000 kgs, then the planner manually calculates from how many kg of birds this can be achieved based on the average weight of the chicken. For every bird of different weight, there is a different matrix associated in terms of yield percentage. for different SKUs like wings, legs, etc. If we have 1.4 kg bird to achieve 10,000 kgs of wings, the planner does this calculation, 10,000 divided by 12.7 percentage, 12.74 percentage. That gives the total weight of the birds required to attain this target. Now the system should propose from what varieties of birds, say 700 grams, 800 grams, and 1,500 grams, this demand. This slide talks about the cut list of chicken. Basically, these are the different SKUs per yield. If you take one whole chicken, it consists of multiple parts. Breast fillet is the most valuable part in chicken. Breast fillet consists of about 25% of the whole chicken. Wings about 12.5%, legs 32.5%, giblets 3.5%, and backbone, etc. will be the balance portion, balance percentage. Okay. So when an order is received for breast fillet, the planner should be able to calculate the number of chicken, average weight chicken required for providing that quantity to the customer. Okay. So system should be able to propose the number of SKUs of chicken required to meet the customer requirement. Okay. Now let's look at the costing component. The costing is a very peculiar thing here in poultry. Okay. So if you look at the parent farms, the parent farm, egg is the most valuable item from a parent farm, because this egg will be hatched and will be sent to either broiler farms or layer farms, which is a finished product again from parent farm perspective. So how do you calculate the cost of each egg and how it should be priced is the most important question every parent farm will face. Okay. There are, by now you must have understood the costing is the most critical function in the poultry. So when we arrive at the cost of egg from parent farm, we should consider the direct costs like feed, medicines, vaccines, and indirect costs like overheads and other expenses. We also need to add the cost of culled birds, bird mortality in the farm, and the cost of rearing male birds for producing these eggs. So the valuation of bird is normally done at flock level. Okay. These are the recommended key processes in SAP. Okay. So on the left side of the table, business processes are given. On the right side, I have mentioned the SAP mapping to be done. Procurement of corn, soybean, live birds, hatchable eggs, etc. can be done using the standard PR and PO functionality in MM. Procurement approvals you can do using release procedure in MM. Feed manufacturing you can use SOP. And the transfer of these poultry products, intermediate products, can be done using stock transport orders in MM. Feed manufacturing specific to a customer or order can be done using make to order production in PP. Quality certificates, they are available in SAP. Material returns, you can use sales return in SD. Inventory valuation is a standard feature in SAP using inventory management. Contract farming can be done using subcontracting or production orders. Recording mortality and culls can be done using production orders in SAP and using quality management module. tracking different age and stage of birds can be done by using some workarounds through custom transactions and tables, because this is not a standard feature in SAP. So some amount of customization is required here. And comparison of standards with the actual performance of birds also needs some kind of customization. We can maintain a custom table wherein we will give the standard industry benchmarks, and actuals can be captured from the transactions and it can be compared. Flock-wise performance of birds in farms can be done using batch management in logistics. Shed-wise performance of birds in farms can be done using production order evaluation in PP. Amortization of bird cost to egg can be done using standard cost estimates and flexible price co-products in CO. Quality checks can be done using inspections in QM. Shelf-life checks for medicines and vaccines can be done using recurring inspections in QM. Formula changes in manufacturing can be done using engineering change management. And loading of male bird costs to females in grandparent and breeder can be done using manual cost allocation in CO. Loading female DOC costs on male DOC in case of respective breed in GP farming, we can do by using in-process inspections in QM. Capitalization of costs in brooding and growing can be done using production order settlements in CO. Receipt of eggs, live birds, skulls and litter can be done through production orders. Apportionment of costs on other products can be done by using co-products and byproducts in MM and PP. So most of these standard requirements of a poultry can be met with standard transactions in SAP, except for a couple of customizations required for tracking age and stage of birds and comparison of standards with actual performance of birds. Otherwise, everything is standard here, which is a good news. So this is typically the functional scope when you go for any SAP implementation in a poultry. These are the sub-modules required in FI and CO. And in manufacturing, maintenance, and QM and logistics, this is the scope. These are the sub-modules required. So now let's see what are the key performance indicators in a poultry. There are a whole lot of other reporting requirements too, but I have picked up the most critical ones here for this presentation. So for farm-wise and shed-wise performance, you need daily farm reports, weekly farm reports, and monthly farm reports. Okay, and for shed performance, FCR and BPC, you need one report for the commercial farms. FCR is the feed consumption ratio, sorry. And for flock performance, yield and DOC, hatchery performance report is required. And for expenses and capitalization of costs, you need growing cost report. For flock performance at farmer's location, you need contract farm report. For batch-wise, flock-wise consumption of medicine, you need medication report and farm medicine and vaccines report.
So we have seen at a very high level what is a poultry, what are the different supply chain components in the poultry, okay, and how the poultry processes and poultry business critical requirements can be addressed through SAP. And we have also seen some of the key performance indicators and reports required. Hope this presentation helps you in meeting your next poultry customer and talking intelligently in his own language. Thank you.